Okay, this is part 2. We're still trying to simplify. In number 13, we have a rational expression divided by another expression. So we had two options. We can either multiply by the least common denominator or multiply by the reciprocal. So I'm going to keep this as m over 5. I'm multiplying by the reciprocal of 5 over m is another m over 5 for a final answer of m squared over 25. In number 14, we have 4 over 25 divided by x over 4 minus 5 over 4. What I'm going to do is multiply both sides by the least common denominator. In this case, it would be 100. And then multiply this by 100. So 4 over 25 times 100 over 1. This is going to be 1. This is going to be 4. I get 16. X minus 4 minus 5 over 4 is equal to x minus 5 over 4. So x minus 5 over 4 times 100 over 1. This is going to cancel and I get 25. So after I multiply, I get 16 over x minus 5 times 25, or 25 times x minus 5. In number 15, I'm going to multiply the numerator and the denominator by 25. A minus 4 divided by 25 times 25 is going to be a minus 4. 1 over 25 times 25 over 1 is going to be 5. My final answer is a minus 4 divided by 5. And then in number 16, this is like 20 over a divided by 16 over a plus 2. So you have two options. You can multiply by a common denominator of a times a plus 2. I think in this case it'll be easier to multiply 20 over a times the reciprocal of 16 over a plus 2, or a plus 2 over 16. So 20 over a times a plus 2 over 16. This becomes 5. This becomes a 4. 5a plus 10 if I distribute, divided by 4a. So we'll have the choice here to either be working in synthetic division or the long division. I'll start off with the long division. I'm not going to be assessing both, but I'll give people the choice to do one or the other. So with long division, it's divide, multiply, subtract, bring down, and then repeat. So I'm taking the first term here, 10x squared, divided by x to get 10x. I'm writing it in the x term here, and I'm multiplying 10x times x minus 4. So I get 10x squared minus 40x. I'm going to subtract, so remember I'm changing the signs of both the 10x and the minus 40. This is like minus 10, this is like plus 40. These cancel, and I'm left with 7x. Bring down the minus 30. I'll do a different color. 7x over x is equal to 7. It's a positive 7, so it's plus 7. 7 times x minus 4 is 7x minus 28. When I subtract, these are eliminated. I'm left over with a negative 2. So write this like minus 2 over x minus 4. So that was the way to do this with polynomial long division. With synthetic division, we're doing the opposite of if it's x minus 4, I want a positive 4 in here. Then my number is going to be 10. Negative 31, negative 30. Bring down the 10. 10 times 4 is 40. 40, then this is going to be 40 plus negative 31. Oh, I'm sorry. No, that's not what I wanted to do. This should have been not 7, but a positive 9x minus 30. And then I would divide 9x by x to get 9. 9 times x minus 4. And I subtract, I'm going to get, this becomes negative, this becomes positive 6. This is going to be 6 over the x plus 4. Sorry about that. So here I get the 10 to 9, and then 9 times 4 is going to be 36. I add to get 6. These are positive, so we're going to be adding them. And it's 10x squared. Math out 10x plus 9 plus 6 over x minus 4. When we have the rational expressions in equations, what I want to do is multiply by the common denominator. In this case, if I have 5v squared, v, and 5v squared, 5v squared is the common denominator. So it's like I'm multiplying both sides of the equation by 5v squared. This would become 6v minus 18. If it's 1 over v times the 5v squared, I get 5v squared over v, or equals 5v. And then v plus 1 over 5v squared is just going to be minus v plus 1. Again, to me, I feel like it's easier to see that this is going to be, and this is 4v plus 1. Two v minus 18 equals 1. Add 18. 2v equals 19. V equals 9.5. When I divide both sides by not v, but 2. And was there another page? No. Oh, wait. I need to change this part here. This was a parentheses, and I forgot to change this one here. That would make this, it's still going to be 5v minus, but then this is going to be 5v minus 1. So I'd get 4v minus 1. This would be a negative 1. And that will turn this into not 19 and v.5, but into 17. And 16 divided by 2 is 8, so this is going to be 8.5. And this last one here, like they did in the section 6.5, we're doing 2 times n minus 6. So we can see that all of the denominators share the factor of the n minus 6. But now there's also the factor of 2. So I'm going to multiply both sides of the equation by 2 times n minus 6. So if it already has the n minus 6 here, this is like 3 times 2, or 6. When I multiply by 2 times n minus 6, I'm left over with 2, and I'm taking away, since this has the same one here, it's n plus 4. But I don't want to make the same mistake as last time. Put some parentheses around that and make sure we're changing the signs for both terms. 2 minus n minus 4 equals 6. This is going to be negative n minus 2 equals 6. Add n but 2. So negative n equals a positive 8, or n equals a negative 8. It says on here to check for extraneous solutions. I talked about it in class, but just want to make sure everyone hears this too. I won't be having any examples where you need to prove that your solution works and then substitute it back in. So if once you solve this, I'm not asking for the second part of it, but I'm more curious, can we set this up so that it isn't a rational expression? Let me know if you have any questions. I'm going to post this review, and there's also the My Math Lab to practice as well. The My Math Lab has like 100 attempts or something, but it won't be actually counted in the gradebook. I just put practice for it. Good luck, and I'll see everybody tomorrow.